planning with the GISMO camera. So what you see there on the picture is the Greenland telescope up at the Thule Air Base in Greenland. So I should acknowledge the people that are involved in this project. So I would say mainly Johannes Stargun at NASA, Elmer Sharp, Steve Mayer, Caitlin Casey, Satoki Matsushita, Mingtang Chen, and Paul Ho at HA. So in this talk, there's going to be sort of, the first half is going to say a little bit about, I'm going to focus on Danish interest in the GLT and a little bit of how we can contribute. And then at the last half of the talk, I'll say about something about this survey that we are planning and scientific motivation behind it. So probably many of you in the room already know what the Greenland telescope is, but maybe people online are not too familiar with it. So the Greenland telescope is essentially, it was the US prototype for the ALMA 12-meter antennas, and it was built by the Vertex. And once the antenna selections were made, this prototype antenna was gifted to Academia Sinica in Taiwan and also the Smithsonian Astrophysical Observatory in the US back in 2012. And then in 2016, it was shipped to Thule, to the American Air Base in Thule in Greenland. And so here it is. It's a nice picture of the telescope here in Greenland. So Thule, just for those of you who are not too familiar with the geography of Greenland, so Thule Air Base is the red dot at the top left corner there. And it's a 12-meter dish. It's an ALMA dish, so it's it's designed for sub-meter observation. It has a 15 arcmeter field of view, and it's currently located at the Thule Air Base, as I said. It is the plan that some years from now, let's say in 2022, that it will be moved to the middle of Greenland, to what is called Greenland Summit. So that's the second red dot on the map of Greenland there. And the reason for that is that there the observing conditions are actually remarkably good. It's clearly a very good sub-meter site that's been established from testing. Now this extragalactic survey that I'll be talking about today, the plan is that we will actually undertake that from Thule, which is near the sea level, but we believe that's doable at 2 millimeters. It's a 2 millimeter survey. But some years from now, we will try and move the telescope to the center of Greenland. So the telescope saw first light at Thule in 2017, and it was some of the first observations were done with a 230 gigahertz receiver as part of the Event Horizon telescope. And then in 2018, first tests were done with a 350 gigahertz receiver. And the scientific motivation behind the Greenland telescope, to start with, was that it was to become part of the Event Horizon telescope, which is this network of a number of radio telescopes around the globe, and of course, with the extension of this array or network of telescopes, extending that with the GLT, we get this much larger northern arm and many more baselines, and thus greater angular resolution primarily. And of course, it was the EHT and that brought us this fantastic image of the supermassive black hole in M87 in 2019. Really a remarkable picture. So from the Danish side, we were approached whether we would be interested in somehow joining the Greenland telescope. And the reason for that is that Greenland is part of the Danish kingdom, and so we can provide a number of logistical, we can help with the logistics, but also there is a strong sub-meter community in Denmark that is interested in utilizing this telescope. So there was formed a Danish Greenland telescope steering group that is now part of the Danish astronomy roadmap. And the Greenland telescope is part of that now. And this steering group, its role is to basically undertake national coordination of basically how we can contribute to the telescope. So that includes science, but also possibly instrumentation, logistics, and maybe even funding. So we have a nice website you can go and look at. So in terms of the logistics, so it's quite a challenge, or it will be a challenge to move the telescope from Thule to the middle of Greenland. Now, as astronomers, we don't really know much about how to do that, but there are really world experts on transportation in Arctic conditions, and also so these are primarily people that have been running ice core drilling camps in the center of Greenland. They have expertise in terms of transporting large structures across the ice sheet. So this is in particular Jørgen Peter Steffensen at the Niels Bohr Institute in Copenhagen has a lot of experience and is sort of leading that effort. And the idea is to basically put the various parts of the telescopes on skis and drag it across the ice sheet. And once it's there, some sort of base camp will have to be established so that people can run the telescope from there. And there are, as I said, already existing ice core drilling camps there, so the EGRIG camp, and the hope is that we can either use some of their facilities, or they can assist us in constructing facilities there. So this is a little bit about the logistics and about this telescope. This telescope, I think, it's sort of like an apex, but in the north, right? It's a single dish sublimeter telescope, and there are a lot of things you can do with it. There are a lot of science you can do with it just as a standalone single dish telescope. You can look at distant galaxies by doing large bolometer surveys, or you can imagine implementing terahertz receivers to do ISM studies in our galaxy. So across all astronomy institutes in Denmark, there is definitely a lot of interest in the GLT and in trying to utilize it scientifically, but also maybe to try and develop new instrumentation. Okay, so I'm going to talk about one such instrument that we have procured, you might say, to bring on the GLT, and that is the GISMO 2mm camera. So GISMO is 128 pixel transition edge sensor bolometer camera optimized for 2mm observations, and it was built by Johannes Stagun at NASA Goddard. And we got funding in this year from the Carlsberg Foundation in Denmark to actually bring the camera to the telescope and also to purchase the various optical components and whatnot that needs to, so that it can be fitted onto the telescope. Now GISMO has been proven to work. It used to be at the IM 30 meter. So here is I would say the main high redshift result that came out of that. So it wasn't there for, I actually forget how long it was there for, but it was a visiting instrument, so it wasn't there for extended periods of time. But it was there for long enough that Johannes could go and target goods north and do a deep exposure, a deep map in that area. So that's the map you see there. So it's basically a 40 square arc-minute field. Goes down to about 0.1 millijansky, so quite deep. And on the 30 meter at 2 millimeters, the beam is about 17 arc seconds. And what you see there are basically a bunch of 3.5 sigma or higher detections. And the squares are the sources that have scuba counterparts. Now the advantage of 2 millimeter compared to say 850 micron that you can get with Scuba 2 is that, so that's the plot on the left there, is that basically the negative K correction is stronger at 2 millimeters than, or it lasts out to longer redshift than 850 microns. So if you have the two wavelength coverages, so let's say you have 2 millimeter with GISMO, and let's say you also have a scuba map, well, then you can go and you can look at these flux ratios. If you can match up the sources, and if you pick the sources with high 2 millimeter over 850 micron flux ratios, then that could be a way of preferentially selecting very, very high redshift dusty sources, so above redshift of 4. So the essence here is that basically 2 millimeters is a very good wavelength if you want to select the most distant dusty galaxies above redshift of 4. At lower redshift, the sources are tend to be too faint, so you kind of filter those out automatically, which is kind of nice. Okay, so this particular survey that we are planning, which we have dubbed the GLT GISMO Extragalactic survey. So we haven't actually undertaken it yet, but once GISMO is at the Greenland telescope, right now GISMO is at NASA, but we have started the work of actually getting it back into shape, as you might say. And the hope is we'll ship it to Greenland next year, and then start observations maybe next summer. But that also depends on the whole Corona situation, because of course the GLT crew hasn't been at the telescope since Greenland was locked down. Okay, so the survey is, we'll want to do a very large survey at 2 millimeters of the north ecliptic field, of course, which is, it's the obvious field to target in that, in the northern hemisphere. It has such a rich ancillary data set. So we see here in the plot, that's from the Scuba 2 NEP survey. So there you see some of the footprints of some of the multi-wavelength surveys of this field. And our sort of fiducial survey numbers at the moment is that we want to survey an area of the order of 5 square degrees, but maybe even larger, and then go down to a noise of 0.5 millijanskis. Now that actually will require thousands of hours, but on the GLT, we believe that that's actually, that's not a crazy request, because the GLT, when it's just at the moment pretty much just doing EHD observations, and there are basically just one target they can target, which is M87. So there's a lot of free time that is not being used, and the hope is that some of that time can be used for this survey, so that over time we can actually get something of the order several hundreds, if not thousands, of hours on this field, which will allow us to reach that depth. The problem is that the beam is somewhat large; it's 40 arc seconds. Right, and so what's the science here? Well, the science, as I said, is to find moderate to bright sources at 2 millimeters. Some of them may be lensed. If we go out to a very large area, we could also go out to maybe 10 square degrees and go a little bit shallower. Then we know from surveys from the SPT, the South Pole Telescope, that or from Herschel, that we find these very bright lensed millimeter sources, and we may pick up some of those as well. But in any case, we will identify massive dusty starburst galaxies at the very highest redshifts, so why do we want to target such large areas? Well, it's basically to try and probe to truly sample the large scale structure of the universe, and to do that, you really need to go above a few square degrees in your survey size. So that's what we try to illustrate at the bottom plots. On the right, you see the simulation of the dark matter density fluctuations at redshift 5, and you see the sort of 2 square degree area of cosmos, and you see the cosmos survey, great as it is, it doesn't quite capture the cosmic variance. And of course, if you then, so that's the dark matter on the right, then we have, in the middle, we have simulations of near-infrared selected galaxies at various redshifts and their magnitudes as indicated by the size of these symbols. And you see the brightest, the most massive sources are, are not necessarily sampled by Cosmos if you happen to be in an underdense region. And then that again ties back into, if you want to study things like reionization, so you look at the left plot, reionization tends to happen earliest in the high density regions, so that's the red regions, and you really need to probe those very overdense regions, as well as the underdense regions if you want to really trace out the reionization history. So bottom line is, you need surveys of the order of several square degrees to really do this. So, and we believe we can do this with our GLT survey with GISMO. So here is just the numbers for that survey, and it's of course worth to compare with another survey that is about to happen, which is the Toltec survey on the Large Millimeter Telescope in Mexico. And I think it's correct to say that survey will be significantly better than what we can achieve with the GLT and GISMO. So the LMT is 50-meter dish. It's a millimeter dish, and Toltec will operate at 1.1, 1.4, and 2 millimeters simultaneously, and the beam, of course, is much smaller as well. So the bottom line is that they can undertake much larger surveys, so of the order of 100 square degrees, down to actually, so there's a large-scale structure survey plan that will go down to the kinds of similar depths that we plan with our survey. But then there's also an ultra-deep field survey being planned that will go down to much greater depths. And with the LMT, they can target NEP, but also other fields, Cosmos, SXDF, and Channel Deep Field South. Now, of course, we hope that we will be able to do our survey before they will. But in any case, I think they will be. It would be nice to compare the two surveys. Let's put it that way. And I actually think we will be on the sky before they will. I think, but who knows? Okay, so just a little bit more context here for why such a survey is interesting. So there is a survey called the Cosmic Dawn Survey, and we believe that both the GLT GISMO survey, but of course also the Toltec LMT survey, will have great synergies with this Cosmic Dawn survey. So the Cosmic Dawn survey is really like a patchwork of existing surveys with Subaru, so the with Hyper Prime Cam, that is led by Dave Sanders in Hawaii. So they got 30 nights. So this is the H2O survey, and they got 30 nights to image with Hyper Prime Cam many of the key extragalactic fields, so the NEP, and also the upcoming Euclid Deep Field, so the Euclid Deep Field South, and also the Channel Deep Field South and Cosmos. Sorry, just the Channel Deep Field South. So you see that's the blue circles there, light blue circles. That's the Subaru footprint. So that data is not completely taken, but getting there. It's getting very close. And this is in the near-infrared filters. And then there's also existing Spitzer data with IRAC. So this was a big program that Peter Kapak had. So 6,000 hours that has also been taken now, almost completed, or they almost got all the data that also targets these fields. And then the green circles indicate the planned LMT survey, which will target the Channel Deep Field South and the North Ecliptic Pole for sure. Now with the GLT, we will do the NEP, so the top left plot there. Now it's interesting, these large surveys, so if you go back to our dark matter simulation that we had before, then we can see that, we have the Cosmos area there in a circle, but then we can also see a single pointing with Euclid, that's about half a square degree, and that will encompass all the deep. Okay, yeah, I'm almost done. So that would basically cover these very large areas. So there'll be a lot of data available from the Cosmic Dawn survey that will allow us to get stellar masses of the subliminal sources that we will see with the GLT and with LMT, and we can push this out to way beyond redshift of 4. and we can try and do stellar mass functions, you know, as obscured versus unobscured star formation rates, and also do abundance matching to get halo masses. And we will have, of course, scuba data of the NEP as well as the GISMO data. So yeah, and as I just want to emphasize, we're really interested in this in Denmark, and not just in the GISMO survey, but also future surveys and endeavors we can do with the GLT. So thank you very much for your attention.
Thank you very much. So now we have some maybe just 2 quick questions. Tomo's point is, if TOTAC is deeper, including the NEP, what's the point of carrying out the GISMO survey?
Yeah, I mean that's a very good point. I think, well, so first of all, as I said, I think it is likely that we will have our maps before they will. So as I mentioned, GISMO has been proven, it works, and we have everything in place. We just need to put it on the telescope. Toltec is a fantastic instrument, but it's also a new instrument. So you know, I don't know enough about the progress they are making. So, but I think we will be first on the sky. We'll see. Maybe I'll be wrong about that. But so you know. And then the second thing I would say is also that for us in Denmark, at least, I think this is an important way of let's say get the foot in the door in terms of showing that you know, Denmark is doing science with the GLT. So it's like getting a foot in the door in various funding agencies, and also in terms of creating like a larger and more sort of permanent engagement with the GLT from the Danish side. So there's also a little bit of political aspect there. Yeah.
Okay, I understand. Can you do this at Thule, or you need to do it at the summit?
We will do it at Thule. So we believe we can do that. So we will do it before the move to the middle of the Greenland. Yes.
Okay, great. So let's thank Thomas again.
Thank you.